So I know that every class at least made it to B here, but did we finish example B? Did we start it? Did we not get to it, Dylan? What do you think? So we did not finish, but we started it. Okay, so let's go ahead and use this as our kind of refresher example to go ahead and talk about a few things. So on the first page, we went through a bunch of vocabulary. We talked about the notation, which uses that little -1 that looks to be a power, but we talked about it's not a power. So if I were to have, f of x, the inverse would be f inverse of x. Okay. There was also another idea that we associated with a horizontal line test. What is that? Okay, 1-to-1. So what does 1-to-1 tell me? If it's a function? No, not if it is a function. If the inverse will be a function. There we go. So let me use these two bars I have here to kind of review those topics. So we have, this is x squared minus 2. It's just a parabola that's been shifted down 2 units. So let me go ahead and grab the vertical here. So if I move this back and forth, is that graph a function? Yes. What the vertical line test is doing, it's visually showing me if any values of x repeat. If any value of x repeats, it's not a function. So if your vertical line touches the graph in 2 or more places at once, we know we have repeating x's. It's not going to be a function. Okay. Well, now let's go ahead and take a look at the horizontal. Does he pass the horizontal line test? Am I ever hitting that graph in 2 or more places at once? In fact, there's a lot of places where I'm always hitting it in 2 places, right? So this guy right now, he is not 1-to-1. Okay? So think about it. If the vertical line test shows me if any values of x repeat, what is the horizontal line test showing me? If any values of y repeat. Okay, so that's really important. So this guy right here, whoops. I love technology. There we go. Let me move this over here. Let's see if I can get that a little better. Maybe like that. So let me go ahead and write out the function. And then I want to ask you why this is important. So let's say this is function f. So we have f of x is equal to, it was x squared minus 2. Okay. So he is a function. He is not 1-to-1. He is not 1-to-1. It's really important that we know if a graph is 1-to-1 or not, because that helps me know something about the inverse. Okay? Like, what would you say about the inverse? Would he be a function or no? No, because here's the idea. When you're talking about inverses, the core idea is that I take the x's, I take the y's, and I do what? I switch them. The x values become the y's, and the y values become the x's. So here, this graph, he failed the horizontal line test because he had repeating y values. So if I take the inverse, those repeating y values will become repeating x values. So the inverse is not a function, and we like our inverses to be functions. So on our last example today, I'm going to show you how to restrict the domain so that that will happen. Now on this one, I'm going to go ahead and graphically show you that's not the case, what we were just talking about. In fact, this line right here, this diagonal, what's that? We haven't brought him up yet. That is y equals x. Yes, that's the linear parent. Okay, y equals x. That's your line of symmetry that you're going to fold a graph across or reflect across if you want to see the graph of the inverse. Now, it may be an inverse function, or it may just be an inverse relation. Okay, so let's see. If I have this point here, the vertex as 0, -2 on the original function, what would that point be on the inverse? It would be -2, 0. Again, all I do is switch the x and the y values. So -2, 0. So I'd have a point here, and he's probably going to look something like that. Okay. So you can definitely tell if I reflect that parabola across y equals x, that inverse is not going to be a function. So he's going to be what we call an inverse relation. An inverse relation. Okay, well, let's go ahead and find what that inverse relation is. How did we do this the other day? Because I've slept since then. I've forgotten. Satish. Set your x's to your y's. Okay, and vice versa, right? So yes, all we do is we take the x and the y and we switch their positions in the equation. So remember, that function notation f of x, that is just y. So I'm going to say x equals y squared minus 2. And now when you solve for y, the result is going to be the inverse. Now whether it's an inverse function or relation depends on what we talked about previously. Okay. Well, what would I do? Add the 2. So x plus 2 is equal to y squared. And now what? Square root. Okay. So the square root of x plus 2, I'm getting a phone call. Yes, that is Mark Hamill as the Joker, in case you didn't recognize it. Okay. All right. So it is the square root of x plus 2 is equal to y. Now, when we're solving algebraically and we take an even root, what do we want to put in front of that radical? The plus or minus. See, that's really important because think about this. The square root of x plus 2, well, that's just the radical parent shifted left 2. So if I don't put the plus minus, I've only got half a parabola. It's that negative that reflects him over and gives me that full parabola that we had right here. Okay? But it's also because of that this guy is not a function. It's an inverse relation. Now, we did this on Friday, and I don't want anybody to be confused. Okay? The very last step, as soon as you figure out what that inverse is, whether a function or a relation, you only replace the y with the notation if it's a function. Okay? Remember, I've already stated several times that this graph here, he is not a function, so I'm leaving it as y. Okay? And I have a text now. Okay, so there we go. All right, questions? All right. Well, let's try another one. Now, I know we haven't gotten to C yet. All right. So I've already got the line y equals x, and let's call this guy something different. Let's call him G. Okay. Let's call that graph G. Okay. So I've already got the line of symmetry, y equals x. The last thing we'll do is go ahead and reflect him. But let's see what we have here. Let me use the mouse again because obviously technology is not 100%. So first off, I'm going to take this vertical line. Is this guy a function? Yes, I am. Now it gets close in a couple places, but we're never hitting him in 2 or more at once. Okay, so this is a function. Now here's my question. Does he pass the horizontal line test? Yes. So this is really important. That means because he's 1-to-1, there are no repeating y's. So what does that tell me about the inverse? The inverse will be a function, and we don't have to do anything to make that happen. Okay. The only time we're going to have to restrict the domain is if our original function or graph is not 1-to-1. Okay, so what parent is this based off of? Or can anybody just tell me what the function is, transformations and all? So g of x equals what? Oh, somebody said it. Cubed root. There we go. This is based on the cubed root parent. But where's he been shifted? Okay, +1 because it's been shifted left. So this is the cubed root of x plus 1. Okay, we said he was a function. He is 1-to-1. Okay. So that automatically guarantees that my inverse will be a function as well. All right. So let's go ahead and find out what that is. So let's see here. I'm going to go ahead and replace the x with y and vice versa. So x equals the cube root of y plus 1. Now, how do I get rid of a cubed root? Cube it, okay. So I'm going to cube the left, I'm going to cube this quantity on the right, and because they're inverses, they're going to undo each other. And remember, that's another thing you should be noticing. When you're dealing with a function and its inverse, you should see or have the opposite operations. Okay, if one is adding a value, then you're going to see subtracting that value in the inverse, okay, and so forth. So x cubed is equal to y plus 1. And last step, x cubed minus 1 is equal to y. Now, let me go ahead and sketch this guy real fast. And if it helps, again, maybe you could take a couple of points off the original and simply reverse it. What would the point 0, 1 become? 1, 0. Okay, what about negative 1, 0? 0, negative 1. Okay, so it's probably going to look something like this. Whoop. I know it's going to hit. There we go. Something like that. Again, it's not perfect because I'm not the world's greatest artist. There you go. But take a look. Doesn't that look like the cubed parent? And all I did was shift him 1 down. Okay. Now, there's something I still need to do to this guy right here. What was I talking about in part B? Was this an inverse relation or an inverse function? Remember, the inverse was a function. So if that's the case, I'm going to replace that y with the notation. See, on B, I didn't replace that y. I left him right where he was because what we got was not a function. Okay. Okay. How are we doing? Are we kind of caught up on inverses? Anybody have any questions? No? Okay, well, let's start comparing quantities. Let's start actually thinking about what a function and its inverse are going to do. So I have some examples here. All right. It says, let C of M. Now, this is the function notation. That's going to be the cost in dollars of M ounces of mangoes. What do the following statements tell you? Be sure to use units. Okay, so C of M is the cost. M is going to be the number of ounces of mangoes that we're able to purchase. Okay, so see, in the original function, my input is going to be the number of ounces, but the output is going to be the cost. So that's really important when we start looking at the inverse and we switch those ideas. So can anybody tell me what statement can you say is happening in A? C of 12 equals 0.75. What was my input? My X value? 12, does that represent cost or ounces? That's ounces, right? So I would say 12 ounces of mango costs what? 75 cents. There we go. I'm still thinking about the input versus the output. What I put in as an X, what I get out as a Y, but we're looking at it in terms of the inverse, the quantities. Okay, like what they actually represent. So let's try B. C of 8 equals 0.5. Raphael, what do you think about that? What statement or sentence can I write? Perfect. He says 8 ounces of mango. I just like saying that word, mango, costs 50 cents. Somebody wants to say that word with me? Mango. A few people said mango. Thank you. Thank you. Okay, just a fun word to say. All right. But now, what's happening in C and D? We've taken the what? The inverse. So think about what the original function is doing. Okay, I'm inputting a certain number of ounces to get out a specific cost. So in the inverse, what am I inputting? This time I'm plugging in the cost to get a certain number of ounces of the mango. All right. So on C, I might go ahead and say something like, how much money is that? $3. So I might say $3, okay, will buy 48 ounces of mango. Mango. There you go. All right. With all the jokes I'm going to be talking about today, by the end, you're probably just going to be like, look, man, go. There we go. I got a laugh right there. There you go. Okay. You laughed. It's funny. Next problem. Okay, D. So C inverse of 0.75 equals 12. Miriam, what would you say here? Okay. So 75 cents, okay. We'll buy 12 ounces of mango. Good. Okay, so we're really going to go ahead and expand on this idea for the next section, and we're going to be looking at two different quantities, but we're going to start changing the expressions. We're almost going to be looking at them with transformations. Okay, so we're going to go through this next part together. Okay, kind of get a little bit of practice. And I've got this cover up so that you don't immediately see what I write. That'll save a little bit of time. Now, just because you may not come up with what I have specifically, can something be said in different ways? Yeah, so just kind of think about that, as we're going through. This is not the only answer that we're going to have. So understanding function notation. Suppose W equals P of X is the average daily quantity of water in gallons required by a palm tree of height X feet. So here's how the function works. Okay, X represents the height of the tree. P of X is the number of gallons that it's going to require based on the height. Is everybody okay with that? So let's take a look at this first one here. What does the expression P of 25 represent? So here's what you have to think. Right, Ethan? Right. Okay. P of 25, is that 25 feet for a tree, or is that 25 gallons of water? What's the input? Okay, so the 25 should represent the height in feet of a tree. Okay, because P of 25 would give you what? The number of gallons of water needed for a 25-foot tall tree. Okay, does that make sense? Okay. Now, you can already see it on your paper. We're now going to reverse this idea. We're taking the inverse. So remember, P of X is the number of gallons that the tree is going to need. So what would P inverse represent? Okay, the water required. Because again, go back to the original function. P of 25, that 25 represents the height of the tree, right? But when we're taking the inverse, what would the 25 represent? The number of gallons of water. So you would have 25 gallons of water needed for this tree. Okay. So do you just want me to go ahead and show you what I have, or does someone want me to, you just want me to go ahead and show you? Okay. I'll just go ahead and do that. So what I wrote was the height of a palm tree that requires 25 gallons of water. Okay. Nice complete sentence. We always like our sentences complete. Okay. And if it's not a complete sentence, let me know, because I'm not an English teacher by any means. All right. So how are we doing with these so far? Okay, problems like these, if you just kind of stop and think about the quantities, it starts to come pretty easy. For these problems, definitely their bark is worse than their bite. Hit the tree joke. You'll laugh later. Okay. So hopefully this isn't stumping anybody. Okay. We'll get to the root of the problem. Okay. At this point, I think I'll just leave it alone. All right. Moving on. I told you I had a lot of puns today. It's going to be a long time until we get to 52. Hang on. All right. C. What does the equation P of V equals 50 tell you about V? So here's the first thing you have to decide. Is V representing the height in feet, or is V the number of gallons of water? Think about how we defined the function P originally. Even though we're using a different variable, it does not matter. The input and the output don't change. So, Christian, what are you saying? So V is just like X, so V is the what?
The height.
So V, you're saying, is the height. So what's that 50? Okay. So let's put that together in a sentence. He's saying that V represents the height of the tree, and that 50 is the number of gallons we need. Would you agree with that? Okay. So someone give me a statement. Stephanie. Okay, there you go. Perfect. Now, how would I rewrite that using its inverse? If P of V equals 50. Raphael? Oh, no, not the statement. I'm talking about the actual expression. So now we want to write it using the notation. So if P of V equals 50, but you are right, okay? Now, what would P of inverse, what would that look like? Now, think about it at the beginning when we had those ordered pairs. What did we do with them? We just switched them, right? So if P of V equals 50, then P inverse of 50 would equal V. There you go. So I said V is the height of the palm needing 50 gallons. Okay. And then P inverse of 50 equals V. Because remember, think about, again, your input versus your output. Okay. A point on this graph would be V50, but on the inverse, that same point would be 50V. Okay. Again, all you're doing is switching what we realize are the X and the Y values. Okay, that's all you're doing here. All right. All right, and I believe we have our last one here for this one. Ooh, that guy jumped up. Okay, palm trees are on average Z feet high, and a tree of average height requires K gallons of water. So we're changing the variables. V now represents our height. Z is going to be the number of gallons that we need. Represent this fact in terms of P and P inverse. Okay, so if you haven't already written it out, take about 20, excuse me, or 25 seconds. So your first statement is either going to be P of Z equals K or P of K equals Z. Once you make that decision, then you'll automatically know how to write the inverse. Okay. So let me give you a few seconds to take a look at that. Okay, so let's see. Who have I talked to today? How about Eric? What would you say? Should I start out by saying P of Z equals K or P of K equals Z? She says P of Z equals K. Is she right? That's exactly right. Because the function P, the output is going to be the water, so it has to equal K based on our height Z. So if I know that P of Z equals K, then P inverse of K should equal Z. Okay, how many people got that right? Good, 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 good. Okay, any questions so far? How we doing? All right, well, let's try this. So I've got a set of 8 based on part D, what we just did. But now we're going to start changing the function, what you would recognize as transformations. But here's one big difference between the two. Hello. Oh, wait, there's coming. Okay. So let's say, forget about the fact that we're talking about trees and water for just a second. Look at P of 2Z. Okay. As far as a transformation goes, what type of transformation is that? And let's break it down. Is it vertical or horizontal? Okay. It's horizontal because it's affecting the input. If you affect anything outside the function, then that's vertical, right? What kind of transformation is that? It's multiplication. So it is a... Erica? Okay, it is a dilation, but it's not a stretch. Now remember, when you multiply your independent variable by a value, you have to take the what? Reciprocal. So if I were to be looking at a graph of this, the transformation would tell me this is a horizontal shrink. It would be half of what it originally was. If I wanted to stretch him, then it would be 1/2 Z, right? Okay. Yes, sir.
So if you do a horizontal shrink, that would be the same as a vertical stretch.
Yes, in fact, I'm hoping that when you were talking about transformations in Algebra 2, you got to the point where you realized if you wanted to affect something vertically, you could alter it horizontally or vice versa. That is absolutely right. One can have an effect on the other. Yes. But now, when we're talking about this, see, we're talking about the real-world application. So take those ideas of the transformations and just put them out of your head, because it's not going to affect the real world. It affects it graphically, but not what we're doing here. Remember, what is Z again? Z is the height in feet, and K is the number of gallons of water, right? Now remember, P of X, P of Z, whatever variable we're going to go ahead and use, that represents the number of gallons of water. So the input here is going to be the height of the tree. So think about, what am I doing to the height of that tree? I have 2Z. And if Z is the average height, what does 2Z represent? Wouldn't that be double or twice the average height? So I would say something probably along these lines. P of 2Z would represent the amount of water needed for a tree twice the average height. Something along that. Okay? So you have to think about what the function represents. Like here, 2P of Z, what are we affecting? The height or the water? The water, because we're outside the function. So you want to think about that when you're going through this. So what I'm going to do, we basically talk through the first one together. Now you've got 7 more. I want you to go ahead and work together, help each other out. Come up with some sentences that describe what's happening here. You got 4 normal function, and then you have the inverse function after that. Okay, so we need a statement written for each one of these. While you guys are doing that, I'm going to pass back the papers I have. So if you already turned in your focus activities, you will be getting those back right now. If you turned them in today, that's still great. I'll get those back to you later. All right. So write down a sentence. The person next to you, we'll go ahead and call him or her your shoulder buddy. Okay, compare answers. See what you got. Okay, Connor's now here. Connor, do you have a pass?
No, it should have been excused.
It should be excused? Okay.
Teachers and students, pardon the interruption. Teachers, all band students should be back in your class
There we
at this
go.
point in time. Thank you for letting them come in a little bit late so that they can get their newscast in. Again, band students should be back in class. Thank you.
Newscast. Were you guys on the news? What was going on? Oh, yeah? Cool. When's the band extravaganza? Tuesday? I don't know. Good. Okay, Zach. Here we go. Susie. Enzo. Varunda. Okay. Jack. Stephanie. Okay. And then I got Enzo. Teach. Jack Williams. Fawaz. Erica. Varunda. Jack. Bless you. Alex is here. Dave. Zach. Kimberly. Scarlett. Susie. Whoop, sorry about that. Rex. Okay. Alyssa. Marion. Shane. Ethan. Juan. Stephanie. Actually, yes, the lowest I got on it was a 40. But I don't believe it was in this class. Okay. Oh, and I did contact Mr. Stewart about your question, what would happen at Chapman, and he said it's the exact same procedure. We would follow the lockout, lockdown, evacuate, or shelter if needed. I'm hoping at some point that the people over there would have talked with you about that, I would imagine, but he said it's the same policy. So I guess if there's something at Chapman, like if it were happening here and you were in the dining hall, I would say, get to a safe place. If it's off Chapman Field, or off that particular place, maybe stay on there, find a safe place, I guess. So I really didn't get a whole lot of clarification on that. He just said follow the same policy. So I did ask about that. Shane, you're welcome. Bethany. Savior. Ford. Jasmine. Christian, Connor, Kyle. Okay, got it.
I didn't realize it was so sick.
What, point while you're running?
Your body.
That's what he's saying. It's like, oh, if they're shooting while you're running, just point in the direction that
And point in the direction you're running or point in the direction of the shooting?
point in the direction that you're running.
Well, maybe that would help other people because, if you're doing that, one, someone's probably going to think that's very odd. But they're probably also going to look in the direction that you're pointing, maybe. But also, if they're that close and there's somebody shooting, I would hope they would already be aware that something's going on. I don't know. Yeah. Yeah. Bethany. Ooh. Okay. Ford. Ariana. And Jacob. Okay, so there's all the papers I've got. Is there anybody who has not gotten through 8? Okay, so you just need about another minute or so? Okay. And I've already written down the responses that I would put. Remember, it's not going to be exactly what I put. Hopefully it's going to be something, similar. All right. We already talked about the first one, P of 2Z. I would say the average amount of water needed for a tree twice the average height. Okay. So let's at least go ahead and get started with 2P of Z. What would I say here, or what could I say? Remember, what were we changing? Stephanie?
I said height of the tree for double the number of gallons.
Okay, so the height of the tree for double the number of gallons? Okay. I think I said mine very similar, just reversed it. I put double the water for an average height palm tree, but we're saying the exact same thing. Perfect. Okay, good. Double the water for an average height palm tree. Well, let's take a look at 3 and 4. Okay, so 3 says P of Z plus 10. So am I affecting the height or am I affecting the number of gallons? Okay, so the height. So what can I say? Okay. I think I started mine off with the water, but you're saying the same thing. Okay. I think I said something, I don't remember, I'll bring down the shade in just a second. I think I said something along the lines of the average amount of water needed for a tree 10 feet taller than average. Okay. What about P of Z plus 10? Who can help me out with that one? Aiden? 10 more gallons of water needed for a tree of average height. I think that's almost exactly what I put. Perfect, yes. Okay, good, good, good. Now, what happens as soon as you get to 5? That's where you're looking at the inverse. Okay, so you're switching these ideas. And we're seeing that variable K. Remember, K represents the number of gallons. So for the inverse, you input a number of gallons of water, and that helps you determine what? The average height for the tree, okay? So what can I say for P inverse of 2K? P inverse of 2K. What can I put? Anybody? Susan. You look like you wanted to put your hand up. You just weren't. Oh, you're okay. You're okay. My mistake. So P inverse of 2K. What would you say here? So think, what are we changing here? Are we changing the height or the amount of water? The amount of water. So specifically, how are we changing the amount of water? Okay, so 2 times more. So 2 times more the amount of water for what? The average height of a tree. Okay, I think that's perfect. Okay, there you go. What about 6? T inverse of k plus 10. Okay. Fawaz, what would you say, sir? The average height requires 10 more gallons. That's a great way to say it. Perfect. Okay, here's what I had on both of these. I put twice the amount of water for a tree Z feet tall, or you could say, average height. Okay. For 6, I put 10 gallons more water. That should probably needed for a tree of average height. I should probably remove that then. Like I said, I'm not an English teacher, so. Because that makes more sense if I take out the then, right? More water needed, more water than needed. Yeah. Yeah. Okay. But it's well, yeah, but I don't know. It just didn't sound right. So I should put the then back.
You can or you can't.
I like you, Jack. Yeah, this may not be an English class, but it's always lit.
Oh,
Literature. You know what? I think that's the biggest reaction I've gotten out of you guys so far this year. So that's the new bar. That's this bar. Okay. That was Dylan. That was good. Really? Oh, come on. Don't get salty, bro. Because that's what you guys say. I try to keep up on the lingo, because I want to be in the teenager's world. Okay. That sounded weird. Okay. Let's get on with the next ones. P inverse of k plus 10. What am I altering here? Am I altering the gallons of water or the height? The height. We are not changing k at all. So what can I say? Anybody? Satish. Okay. Number of gallons needed for a tree 10 feet taller than average. Okay. And who was it who was also answering at the same time? Okay. Jane, why don't you help me out with the next one? P inverse of k minus 2. She says the amount of water needed for a tree 2 feet shorter. Okay. 2 foot shorter. All right, and let's see what I got here. Water needed for a palm 10 feet taller than average, and water needed for a palm 2 feet shorter than average. Perfect. Perfect. Are we getting the idea? Okay. All right, good. Well, let's go ahead and get back to a little math here. So we've already really talked about these. These steps now for finding an inverse are just kind of written down for us. In order to find an inverse, 1, determine that an inverse exists, meaning is it 1-to-1 or not. If it is 1-to-1, you got no worries. You can just continue the problem. If it is not 1-to-1, you need to restrict the domain in some way so that it will become a function. We always want our inverse to be a function. So we interchange x and y in the function, the formula. We solve for y to get the inverse. And then our last step, because we're going to guarantee that our inverse is a function, we're going to replace it with the inverse notation. Okay, so let's take a look at a problem here. 4a. All right. And we may not finish this, and that's okay. We'll go ahead and, take care of the rest of it tomorrow. Probably D, the last part where we're going to verify that they are inverses. But we want to sketch the function, find the inverse, sketch the inverse. Okay. So let's see here. F of x equals 2 minus x squared. All right. What is that going to look like graphically? What parent is he? He's a parabola. Now, he's opening down because of the negative. It's a reflection. And what about that 2? Yeah, it shifted everything up too. So the vertex should be at 0, 2. All right. And if you were to do a little more analysis, you're going to find that the roots are about plus or minus 1.41 because you'd be taking the square root of the 2. So I'm going to draw like this. Okay. All right. So if I were to put a vertical line through him, is he a function? Yes, he is a function. Is he 1-to-1? No. He fails the horizontal line test. Okay, there's several places where he's going to touch that horizontal line in 2 places. So here's what we're going to do. Because he is not 1-to-1, I know that my inverse is not going to be a function. So his domain, negative infinity to positive infinity, I need to decide how to restrict him. So what I typically tend to do, just because it's what I've always done, I tend to lean more towards the positive. So to make sure that this graph, this function is one-to-one, I'm going to restrict his domain to everything from 0 to infinity. His domain is everything from 0 to infinity. What's his range? From negative infinity to 2. Okay, to 2. Okay. So I am starting off the problem restricting his domain because I want to guarantee that inverse is a function. So I can now say, because of that restriction, this guy is one-to-one. But there's probably some folks out there thinking, okay, well, how did you make that decision? Is there anything saying that when I'm looking at the full parabola that I couldn't have just cut off his right side? Would that still work? Yeah, absolutely. Really, it just comes down to however you want to restrict it. As long as you end up where it's still a function and it's one-to-one. But you have to understand the one we're going to be working with is on the right, correct? If I had worked with this guy on the left, would the inverse look different? There would be a slight difference. So it does depend on how you're going to restrict him. And I'll talk about that in just a second. So here, we're just going to be looking at this guy. So there's really no right or wrong. It's really just how you decide you want to go ahead and do it. I typically go for the positive. Okay. So let's go ahead and find his inverse. X equals 2 minus y squared. Okay, now what? Do what? Okay, subtract the 2. So x minus 2 is equal to a negative y squared. There's something I got to take care of before I take the... I mean, you could have added the y over. But typically a lot of people, when they tell me to do these things, we freeze that dependent and we move everything else. But you absolutely could move the y if you want to. Because it's still going to have the same effect. Because now whether I multiply or divide by negative, I'm going to end up with positive 2 minus x is equal to y squared. Okay. All right. And now how do I get rid of the square? We take the square root. Now you remember that first problem we did today? I think it was 1b or something like that, where we knew that the inverse was not going to be a function. Okay. Well, this is where you got to be careful. I am solving this algebraically. Would I put plus minus in front of this? I would not. Because remember, if I put the plus minus, that's going to give me a full sideways opening parabola, and it's not going to be a function. We restricted his domain because we want him to be a function. So we're going to end up with the square root of 2 minus x is equal to y. Now, can I replace the y? Yeah, because we guaranteed this was going to be a function. So I'm going to replace him with f inverse of x. Now, if I were to go ahead and reflect this guy across this one right here, okay, like 0, 2 would become 2, 0, you're probably looking at something like this. Okay. Now, here's what's really cool about this. Okay. The domain of the inverse would be the range of the original function, right? Negative infinity to 2. The range of the inverse would be the domain of the original function, 0 to infinity. Now, compare that domain and range to the graph I just sketched. Does that fit? Fits it perfectly. Okay. There we go. In fact, very quickly before the bell rings, can anybody tell me if I were to go ahead, if I had restricted him to negative infinity to 0, how would that change the inverse? What would I have to put on the outside of it? I would have to say negative 2 minus x, because look at his reflection there. So it does matter where you go ahead and restrict it, but it's always up to you. Does that make sense? Okay, we'll continue this tomorrow. Guys, thank you. Have a great day. See you tomorrow.